yesterday we started a set of notes here on kinematics, and I think I actually got myself zoomed in a bit here. All right. We were talking about the difference between distance and displacement. We talked about the difference between speed and velocity, right? There's displacement. Remember, displacement is how far you are away from where you started. Displacement and velocity are both vector quantities. We talked about constant speeds, which give us a straight line. We calculated the slope of these lines. We know that the speed for line A is faster than B, and that's faster than C because it's steeper, right? We talked about average speed, which is the total distance divided by the elapsed time. We talked about average velocity, which is the total displacement by the elapsed time. And we know that both of them use this formula right here, right? Which you guys have used, I think, in grade 10. Okay, and there's a quick example, right? Here is average velocity. If you go forward and backwards, you have to account for the direction. Here I went 80 forward and 30 backwards, so I have a displacement of 50, and I divide that by my time, right? These are all examples of constant velocity, straight line graphs, and we know that the slope between A and B is going to be the same as the slope between the start and the finish, right? And then this is sort of where we left off here, is that the realization that most trips do not happen at a constant velocity. Usually you have to speed up at the start and slow down at the end, sort of like Felix there. He's going to basically go from 0 to, how fast was it? 700 miles an hour in 35 seconds.
What if he hits a plane on the way down?
Actually, that's a great question. They actually put reflective tape on his suit, and so that he will show up on radar. So air traffic control will be notified that he's going up, and he will become like a little blip on the air traffic control screen.
Would he probably go straight through the plane if he actually did?
Yeah, like at that speed, yeah.
Really?
Yeah. Oh, yeah. Is it like 1,000 kilometers an hour?
Man-shaped hole.
No, he survived that.
Yeah. It might be more appropriate to say the plane would go through him too. Probably a little bit of both. Yeah. Okay. So where I left off was talking about instantaneous velocity. Okay. So now's the point where you really need to sort of tune in the attention here. So instantaneous velocity is the slope of the curve at a single point or instant. Now, when you find slope, you need 2 points, right? One up top, one down below. You need 2 points. To do that, we're going to find the tangent, right? And the tangent line I showed you yesterday is just a line that is the same slope as the curve at that point, and it just touches the curve at that single point. Now, how do you come up with that? You put your ruler on and you guess. Okay? Now, is Mitchell going to have a different tangent line than Luke? Probably. That's okay, right? As long as the process is there. Okay. The other way to figure it out is to go into calculus. When you take pre-calculus, well, that's obviously the precursor to calculus, right? Once you go through all that calculus stuff, it turns out it's actually pretty easy to find the slope of the curve. But you got to do all the mumbo-jumbo theory stuff ahead of time. So, okay. All right, so I don't think we've gotten this far yet. So now you should have this graph here, right? So here's a graph of what we call variable motion. And variable simply means what? It varies. It changes, right? The motion is changing. How can I tell? Because the graph is curved. Okay, the graph is curved. This you need to pay particular attention to. All right. So what is the overall average velocity? Okay. Well, we have to find the displacement. Okay. And in fact, I would suggest you just put your pencils down and just watch. And I'll give you a chance to copy this down in a second. Okay. Just put your pencils down, your glue sticks, your pens, your scissors, whatever you're doing there. Okay. The overall displacement, it starts at a position of 0, and it ends up here at
7.
7, right? It ends up here at 7. So the displacement is 7 minus 0. I went 7 meters. And it took me 0 to 11 seconds. It took me 11 seconds. And so my average velocity is 0.64 meters per second. Is there any point on that curve where the slope is 0.64 meters per second? Like, in fact, the 0.64 meters per second, let me just draw a line on here, is really, if I do this, if I find the slope of that black line, the slope of that black line would be 0.64. Okay? Now you'll see if I grab the line here, is the slope of the line the same as the curve way down here, where the cursor is? No, the curve is flatter, isn't it? right? Is there any point on the line where the curve is about that? Somewhere in there, right? Around about 3 seconds, 3¼ seconds, something like that. Somewhere in there. Here the curve is steeper, and there's some point up there. So there's really only probably 2 instants where the slope of the line is 0.64, but the overall average is 0.64. It's no different than getting a 60 on one test and a 68 on another test, right? What's your average? 64. Did you ever get a 64? No. The average. Okay. Now, what about the velocity? What about the velocity between points C and D? I'll put this one back up here like this. The average between points C and D. I'm going to draw a line between point C and point D, and I'm going to make it a different color too.
Make it purple.
Okay. Okay, so to find the average velocity between C and D, I find the slope between C and D. I started at position 2, I went up to position 4. So my displacement is 4 minus 2, or 2. The time was from 4 to 6, so my time difference is 6 minus 4 is 2. The slope of the purple line is 1. You'll notice that it's steeper than the black line. Okay? Are there any times when the instantaneous velocity is 1? Yeah, likely, somewhere. Somewhere in there, right? That would be about the only time. Okay, I'll give you a chance to jot that down. So when I give you a curved graph like this, I can ask you many different things. I can ask you for the total average velocity. That would be always like from where you start to where you end. I could ask you to find average velocity between 2 points, or I could ask you to find instantaneous velocity at a single point. I haven't yet shown you that yet, but I've shown you 2 examples here. Overall average velocity, start to finish, average velocity between 2 single points. So this last one here, same graph, the velocity at a single point C. So what I'm doing here is I'm asking you for what's the velocity at point C. So how would you do it? Well, you would take out a ruler. You would make yourself a line, right? And no, would you measure it? You would put your ruler on there so that it just touches point C, right? And then you would extend it as far as you can, okay? And you would pick what I call lattice points. These are called lattice points right there. They're right on the grid, okay? Now that's not always going to work. Okay, I'm going to expand this line here like this. Right? You would go as far as you can. Oh, that actually worked out pretty good right there, right? And there didn't really appear to be one down here. Okay? Do the points have to be at either side of the, like, could I have picked that point? Could I use that point there for my slope? And, well, that one's not quite right on, right? But if it was right on it, could I use it? Sure, why not? Okay, they don't have to be on either side. They don't have to be the end points. They just have to be 2 points on that line. Okay, so what I did on the side here was I used these end points right here. I drew a little triangle on there. Okay, and I used those points right there. So this point right here, what's the y value of this point right here? 3.2. The y point of this value right here is 0.8, right? So this height here is 2.4. 3.2 minus 0.8 is 2.4. That's the height there. That's the rise. Okay, the run goes from about 2.5 to about 5.8. So this distance here is my run, which is 3.3. Okay, and then I find the slope, and I get the instantaneous velocity of 0.73.
Just for that point.
Just for that point. Okay? It's how fast it's going at that point. Somewhere, yeah. Where's yours? Oh. Yeah, I'll find you one. Not sure where.